right, diving right in, folks. We've got, today's deep dive is all about, you guessed it, lifelong learning LLM agents.
Oh, yeah.
You sent over some really cool papers on this.
Yeah.
Um, Lifelong learning of large language model-based agents,
Mm-hmm.
a roadmap,
Mm-hmm.
collaborative learning and multi-agent LLMs,
Yeah.
and, memory systems in large language models.
It's a good one.
Like,
Yeah.
it sounds pretty dense, but also, like, incredibly cool.
Right.
So I'm excited to unpack all this with you today.
Yeah, me too. It's a pretty hot topic right now, so.
Yeah. So, I guess, like, just to set the stage for anybody who's not super familiar, these LLM agents, they're these, like, autonomous entities, right?
Mm-hmm. Yeah.
And they basically use large language models as their brains,
Mm-hmm.
which is just, it's kind of mind-blowing when you think about it.
Yeah.
It's not just like, spitting out text or something. They can actually interact with like, their environment, like take actions and all that.
Yeah.
Which is a huge shift, I think, from how we've traditionally thought about AI.
Right. Like when you think of an AI, you usually think of like Siri or Alexa, right?
Mm.
They're pretty good at like specific tasks.
Yeah.
But these LLM agents,
Yeah. This is like next level.
they're like way more capable, way more adaptable.
Definitely. And that's where this whole concept of lifelong learning comes in.
Right. Like imagine like an AI that not only understands what you're asking it,
Mm-hmm.
but it can actually learn from its experiences
Right.
and like actually get better over time at doing what you want it to do. Like that's the promise of this whole lifelong learning thing.
Yeah. And that's a big change from the more traditional AI that we used to see.
Yeah. So I guess like to kind of kick things off, why is lifelong learning such a game changer in AI?
Well, I think one of the biggest reasons is that, traditional AI models, they're pretty static, right?
Mm.
They're trained on like this fixed set of data. They're good at one specific task, but they don't really evolve or adapt, right? Like they can't really learn new things or adjust to like new information or situations.
Exactly. And that's what lifelong learning is all about.
Yeah.
It's about creating AI that can actually, continuously learn and grow and
Mhm.
really mimic how we learn as humans.
Okay, so it's almost like trying to create an AI that's more like a student, right? Like someone who can learn new subjects and build on their knowledge.
Yeah, that's a great way to think about it.
Yeah, versus like a calculator that's just stuck doing the same thing over and over again.
Exactly. It's about moving beyond those limitations.
So you're saying this is like a huge leap forward, then going from these static models to these like interactive learning LLM agents.
Oh, yeah, absolutely.
Okay. So how did we even get here? Like where did this whole idea of lifelong learning come from?
Well, it's been a long journey, really. People have been exploring the concept of lifelong learning in AI for decades,
Mm-hmm.
but there have been these like 4 key stages that have led us to where we are today.
Oh, okay. What are those?
Well, first you had the foundational concepts, right?
Right.
Like back in the 80s and 90s, people were starting to lay the groundwork for what lifelong learning could look like in AI.
Okay.
And then came what's called deep lifelong learning.
Oh, cool.
This is where, deep learning techniques started to be applied to lifelong learning and things really started to take off.
Mm.
Then, of course, we have the rise of LLMs, these large language models,
Right.
which, have been a game changer for so many areas of AI.
Yep, definitely.
And now, finally, we're seeing the emergence of these LLM agents that can actually leverage lifelong learning to become even more powerful and versatile.
So it's like each stage has built on the previous one to get us to this point where we're at, like with these agents that can truly learn
Yeah.
and adapt.
Yeah, exactly.
That's really cool. But I mean, it sounds like there must be some serious challenges too.
Oh, yeah. Lifelong learning isn't a walk in the park,
Yeah. What are some of the biggest hurdles that researchers are facing?
Well, one of the big ones is something called catastrophic forgetting.
Catastrophic forgetting. That sounds pretty intense.
It is. It's basically when an AI, kind of like humans sometimes, forgets old information as it learns something new.
Oh, I see. So like it learns how to do one thing really well, but
Yeah.
then when you try to teach it something new, it kind of like overrides the old knowledge.
Exactly. And that's a big problem if you want an AI that can continuously learn and grow without losing all the progress it's made.
Yeah, that makes sense. So it's
Yeah.
like it's almost like it needs a way to like remember everything it's learned while still being able to like take in new information and adapt.
Yeah, and that's one of the key challenges in lifelong learning research. How to create AI systems that can retain knowledge, avoid catastrophic forgetting, and keep building on what they've already learned.
Okay, so like we've got these LLM agents that can learn and adapt. They have to overcome this whole catastrophic forgetting thing.
Yeah.
But like, how do they actually work? Like, what's going on under the hood?
Well, it's pretty complex, but basically these lifelong learning agents, they have 3 core modules that allow them to learn and interact with their environment.
Okay.
And those are perception, memory, and action.
Perception, memory, and action. All right, let's break those down.
Sure. So starting with perception, this is how the agent kind of sees and interprets the world around it.
So it's how it takes in information, kind of like our senses.
Exactly.
Okay, but is it just about like processing text, or can these agents perceive other types of information too?
It's definitely not just text. In fact, these agents are designed to handle what's called multimodal input.
Multimodal input. Okay, so what does that mean?
It means they can take in information from all sorts of sources, not just text, like images, sensory data, you name it.
Oh, wow. So they can actually like see and hear and maybe even feel things, kind of like us?
Yeah, in a way. They're designed to be much more adaptable to the real world, which is full of different kinds of information.
Right, like if it could only process text, it would be pretty limited in what it could do.
Exactly. Multimodal perception is key to making these agents truly versatile.
Okay, so we've got perception covered. Now, what about memory? Like, how do these agents actually store and remember all this information they're taking in?
Yeah, memory is where things get really interesting.
I bet. And it's not just like one big memory bank, right?
No, not at all. The research talks about these 4 different types of memory: working memory, episodic memory, semantic memory, and parametric memory.
4 types. Okay, I'm already feeling a little overwhelmed.
That's a lot, I know. But each one plays a crucial role in lifelong learning.
Okay, so maybe we can break it down one by one. What's working memory?
So working memory is kind of like the agent's mental scratch pad. You know, it's where it holds the information that it needs to access really quickly, like the current task it's working on or recent interactions it's had.
Okay, so it's like short-term memory. Like when I'm trying to remember a phone number someone just told me.
Yeah, exactly like that. It's about holding on to information in the moment.
Okay, but our short-term memory isn't exactly known for being super reliable. Like I can barely remember what I had for breakfast sometimes. So how do these agents manage their working memory?
Well, it's definitely a challenge because working memory has limited capacity, just like ours. But researchers are working on ways to help these agents manage that limited space.
Okay, like what kind of things?
Well, one approach is something called prompt compression.
Prompt compression, what is that?
It's basically about trying to condense information without losing those important details, kind of like teaching the agent to take really good notes.
Oh, I see. So instead of trying to remember every single word, it learns to focus on the key points.
Exactly. It's about finding that balance between efficiency and accuracy.
Okay, so that's working memory. What about episodic memory? What's that all about?
Well, episodic memory is all about remembering specific events or experiences.
Oh, okay. So like if it had a particularly challenging interaction, it would store that memory away.
Yeah, exactly. And then it can draw on those past experiences to make better decisions in the future.
So it's like the agent's personal history book.
Yeah, you can say that. It's constantly adding new chapters based on its interactions and the outcomes of its actions.
That's pretty cool. Okay, so 2 down, 2 to go. What's semantic memory?
So semantic memory is all about general knowledge about the world.
Oh, okay. So like facts and concepts, kind of like an encyclopedia.
Exactly. It's where the agent stores its understanding of, things, ideas, relationships between things.
Right. But like the world is constantly changing, right?
Yes.
New information is always coming out. So how does an agent keep its semantic memory up to date?
That's a great question, and it's something that researchers are working on actively.
So what are they doing?
Well, there are a couple of key approaches. One is called continual knowledge graph learning.
Continual knowledge graph learning.
Yeah, it's basically about helping the agent understand the relationships between different concepts and facts, kind of like building a web of knowledge that it can use to reason and solve problems.
Okay, I can kind of picture that. Like it's not just memorizing isolated facts, it's understanding how they connect to each other.
Exactly. And then the other approach is called continual document learning.
Continual document learning. Okay, what's that one all about?
So imagine the agent has access to like a massive library of documents like Wikipedia or scientific journals.
Okay.
With continual document learning, it can actually continuously scan these documents, extract information, and update its semantic memory with new facts and insights.
Oh, wow. So it's like it's constantly reading and learning to keep its knowledge base up to date.
Yeah, exactly. It's like having a built-in research assistant that never sleeps.
That's incredible. Okay, so that's working memory, episodic memory, semantic memory.
Hmm.
And that leaves us with parametric memory, which sounds like the most mysterious of the bunch. What's that one all about?
Yeah, parametric memory is a bit more abstract than the others. It's not like it's stored in the specific location. It's actually embedded within the structure of the large language model itself.
Okay, so it's like the knowledge is kind of woven into the very fabric of the AI's brain.
Yeah, that's a great way to think about it. And it's shaped by all the data that the model has been trained on, all the fine-tuning it's gone through.
But how does the agent actually use that embedded knowledge?
Well, it's not something that the agent consciously retrieves or manipulates.
Really?
It's more like it's implicit knowledge that influences its understanding and behavior. It's what allows the agent to recognize patterns, make inferences, adapt to new situations based on its cumulative experience.
So it's almost like intuition or common sense in humans, like that kind of knowledge that's hard to explain, but it just kind of guides our decisions.
Yeah, exactly. And as the agent continues to learn and interact, its parametric memory is constantly being refined, leading to a more nuanced understanding of its environment.
Okay, so we've got these four types of memory working together, creating this incredibly sophisticated learning system. It's taking in information through perception, storing and processing it in these different types of memory. But the big question is, how does all of this translate into action? Like, how does it actually do things in the world?
Yeah, that's a great question. And that brings us to the third core component of these lifelong learning agents, the action module.
Okay, let's dive into that.
Let's do it.
All right, the action module, this is where we see these LLM agents actually putting all that learning to work. Right?
Yeah.
Like, it's not just about thinking and understanding, it's about actually doing something with that knowledge.
Exactly. It's about making things happen in the real world.
Okay, I'm ready to see how they do it.
All right, let's get into it. So the action module, right? This is where things start to get really interesting. It's like, how did these agents actually translate all that knowledge and understanding into real world action?
Yeah, exactly. Like the real world is messy and complicated. How do these agents even know where to begin?
Well, just like we break down tasks into smaller steps, these agents rely on what are called grounding actions.
Grounding actions. Okay, I need like a visual here. What does that even mean?
So imagine you've got an agent, right? And it's designed to help you, I don't know, with tasks on your computer.
Okay.
A simple grounding action might be like understanding that the phrase open a new document
Right.
means it needs to interact with your word processing software and execute the commands to like create a blank document.
Okay. So it's like it's got to learn to speak the language of that specific environment, right? Like
Yeah.
it needs to know how to translate those like abstract instructions into the actual concrete actions within that system.
Exactly. And even those what seem like really simple grounding actions can involve a lot of like behind the scenes work.
Right.
The agent needs to like understand the structure of your operating system, the commands within the program, the sequence of actions to get that outcome.
Wow. It's making me realize how much we like take for granted when we just like open a document on the computer.
Oh, yeah,
But
totally.
that those basic grounding actions,
Yeah.
that's just the starting point, right?
Yeah. So once the agent like gets how to operate within its environment, it needs to be able to like access and use the information stored in its memory, right?
Okay.
And that's where retrieval actions come in.
Retrieval actions. So that's about like pulling out the right information at the right time.
Exactly.
But
Like these actions let the agent tap into like its semantic memory, its episodic memory to find, relevant information to guide its actions.
Okay. So like, for example, if I ask it to, find me a recipe for chocolate chip cookies,
Yeah.
it might use retrieval actions to like pull up, ingredients, baking temperatures, maybe even like past experiences I've had with making cookies.
Exactly. It can use like its general knowledge, right, about baking
Okay.
and combine that with any specific info it has about like your preferences.
Okay, that's cool. But we're still talking about like relatively simple actions here. What about more complex tasks? Where the agent has to actually like think things through, come up with its own solutions.
Yeah. Well, that's where we get to reasoning actions.
Reasoning action.
These are like the most sophisticated actions in the agent's toolkit.
Okay.
And they involve using like logic and deduction, problem solving to actually figure out the best way to go about something.
So it's not just following instructions or retrieving information.
Yeah.
It's actually like using its knowledge to like reason through a situation.
Yeah, exactly. And this is where the real power of lifelong learning comes in.
Right. Because if it can learn from experience, apply that knowledge to like new situations, it can like come up with solutions that we might not even have thought of.
Yeah.
Okay, that's amazing. Can you give me an example of like a real world reasoning action? Something I could actually picture.
Sure. So remember that online shopping agent we talked about before? Imagine you ask it to like put together an outfit for an upcoming wedding.
Okay, yeah.
That's way more complex than just retrieving a list of dresses and shoes.
Right. There's like the dress code, the weather, my personal style, budget, like so many things to consider.
Exactly. And the agent needs to use those reasoning actions to take all of those factors into account, right?
Mm-hmm.
To find an outfit that actually works.
Okay.
So it might like realize that a dress you like is way out of your price range and suggest a similar but more affordable alternative. Or it might understand that an open-toe shoe isn't the best choice for an outdoor wedding in December.
So it's like having a personal stylist and a financial advisor all rolled into one.
Yeah, exactly.
But with the added benefit of like learning my tastes over time and getting better with each interaction.
Yeah, and that's the beauty of it.
Okay, this is incredible. But I have to imagine teaching an AI how to reason, like that's got to be pretty difficult, right?
Yeah, it's definitely one of the most challenging areas of AI research.
So like, how are they even approaching this?
Well, one technique is called chain of thought prompting.
Chain of thought prompting. Okay, I need that visual again. What is that?
So it's like researchers guide the agent through a series of logical steps to help it break down a problem and arrive at a solution.
Okay, so it's like they're giving it a mental roadmap, showing it how to think through a problem step by step.
Exactly. And as the agent gets more practice, it starts to like internalize those thought processes and it gets better at solving problems on its own.
Okay, that makes sense. So we've got grounding actions, retrieval actions, reasoning actions. These all sound like essential, right?
Mm-hmm.
But are there any like challenges that researchers are facing when it comes to building these action capabilities into these agents?
Yeah, for sure. I think one of the biggest ones is making sure that these agents can adapt their actions to different environments.
Okay. Yeah, that makes sense. Like, it's one thing for an agent to learn how to do something in a controlled environment, like a simulate. But the real world, it's unpredictable. There are all sorts of variables.
Exactly. It's a whole different ballgame.
So how are researchers trying to tackle this challenge of, making sure the actions work in different environments?
Well, one strategy is to like focus on developing agents that are designed for specific types of environments.
Okay.
So, an agent that's designed to like help with tasks on a computer would need different capabilities than one that's, navigating a website or playing a game.
Right. So it's like you're tailoring the agent's actions to the specific demands of the environment it's going to be operating in.
Exactly. It's about recognizing that like one size doesn't fit all.
That makes sense.
Yeah.
But even within those specific environments, there's still going to be a ton of variability, right?
Right.
Like the real world's not always going to play by the rules.
Totally. And that's why another big area of research is focused on continual adaptation.
Continual adaptation?
Yeah, it's about giving the agent the ability to constantly monitor its environment, detect changes, and adjust its actions accordingly.
Oh, so it's like it's got these reflexes almost, right? Like it can respond to something unexpected happening.
Yeah, exactly. And that continual adaptation, that's crucial for lifelong learning.
Okay, so we've got these grounding actions, retrieval actions, reasoning actions. We've talked about adapting to different environments.
Yeah.
But is there anything else about like this action module that we should be thinking about? Any other like key concepts or challenges?
Yeah, there's actually one more distinction that's really important.
Okay, what's that?
It's the difference between input grounding actions and output grounding actions.
Input grounding and output grounding. Okay, that sounds interesting.
Yeah.
Break that down for me.
So think of it this way. Input grounding actions are all about understanding and interpreting like the information that's coming in from the environment.
Okay.
It's about making sense of what the agent is perceiving.
So if I tell it like I'm feeling hungry, it needs to use input grounding actions to understand what that actually means, like in the context of, what it's doing, what its goals are.
Exactly. It might need to access like its semantic memory to understand hunger, its episodic memory to recall past experiences with food,
Okay.
maybe even its parametric memory to factor in like your preferences.
Okay, that makes sense.
Yeah.
So then what are output grounding actions?
Output grounding is like the flip side.
Okay.
It's about taking that internal understanding, those decisions the agents made, and actually translating them into concrete actions in the environment.
So if the agent decides like, okay, the best way to deal with this hunger is to order a pizza.
Yeah.
It needs to use output grounding actions to make that happen, like actually interact with the food delivery app, choose a pizza place, all of that.
Exactly.
Wow, so much goes on behind the scenes to make even these simple actions work.
Yeah.
But I'm starting to get a better picture of like how these agents can actually understand the world and do stuff in it.
It's pretty cool, right?
Yep.
It's like we're just scratching the surface of what's possible with these agents.
It's exciting. But before we get like totally lost in the future, I want to shift gears for a second, talk about like the social side of these LLM agents, because I'm really intrigued by this whole idea of collaborative learning in multi-agent systems.
Yeah.
Like the paper collaborative learning in multi-agent LLMs, that was fascinating. Seems like there's like a ton of potential there.
Oh, absolutely. The idea that agents can learn from each other, not just their own experiences, that's powerful.
Yeah. So instead of each agent being a lone wolf, figuring things out on their own, they can actually work together, share their knowledge.
Yeah, it's like teamwork for AI.
Exactly.
Yeah.
Okay, so like, how does this actually work in practice? Like, how do these agents communicate, share their insights with each other?
Well, there's like a few key mechanisms at play.
Okay.
One is knowledge sharing and transfer.
Okay.
This is where agents literally share what they've learned, either through like direct communication or through some shared knowledge base.
So like one agent's like, hey, I figured this out. Here's the shortcut.
Exactly. And that can be super efficient, right? They can benefit from each other's successes and avoid repeating like the same mistakes.
That's cool. But beyond just sharing information, can they actually learn from each other's actions, like their experiences?
Oh, yeah, definitely. That's where the concept of like shared experiences and collective learning comes in.
Okay.
So imagine a bunch of agents, they're all operating in the same environment, like a simulated city or a game.
Okay.
They can watch each other, see what works, what doesn't, and learn from those shared experiences.
So it's like a group project, but for AI.
Yeah. And that collective learning can be super powerful, especially for complex tasks that need like different perspectives.
Okay, this is really cool. But like zooming out a little bit, what's the like big picture impact of this multi-agent collaboration?
Well, I think it has the potential to like really accelerate the pace of AI development. Imagine a world where AIs are constantly learning from each other, building on each other's progress.
Yeah.
It's like this snowball effect, right? Knowledge just keeps compounding. And it's not just speed, it's also like diversity.
Okay.
You encourage collaboration between agents that have different experiences. You get more creative, more robust solutions.
So it's like moving away from that idea of like a single all-knowing AI
Right.
and toward a more like decentralized collaborative system where multiple agents are working together.
Exactly.
Okay, this is all super fascinating, but are there like any challenges or risks associated with this approach?
Oh, yeah, of course. With any new tech, there's always like challenges.
Yeah.
One of the big ones with multi-agent collaboration is like making sure they can actually communicate and coordinate effectively.
Right, because if they can't understand each other or their actions conflict, that's going to be a problem.
Yeah, it's like a team project where nobody's on the same page.
Right, exactly. So how do you like avoid that?
Well, researchers are working on like robust communication protocols, coordination mechanisms to make sure the agents can work together smoothly.
Okay, that makes sense.
Hmm.
Anything else we should be thinking about? Any other risks?
Yeah, another thing to consider is like bias amplification.
Bias amplification.
Yeah. So if agents are learning from each other, there's a chance that like biases in one agent's data
Okay.
could get amplified, spread through the whole system.
Okay. So it's like the echo chamber effect we see on social media, right?
Yeah.
Like biased information can spread really quickly and just reinforce like existing prejudices.
Yeah, that's a good analogy.
Okay.
So researchers are looking at ways to like mitigate that bias amplification.
Okay. How do they do that?
It involves like carefully designing the algorithms, making sure there's diversity in the training data, having ways to detect and correct bias.
So it sounds like there's a lot of responsibility here to make sure this is done ethically.
Oh, absolutely. But the potential benefits are huge.
Yeah.
And I think with like careful and responsible development, this collaborative approach can really help us unlock a new era of AI.
Okay, so we've talked about like how these lifelong learning agents work. Perception, memory, action.
Mm-hmm.
We've gone deep on collaborative learning, but there's one more piece of the puzzle, right?
Yeah.
How do we even know if these agents are actually effective? And what are some of the like real world places where they're already being used?
Those are great questions. And I think they really highlight what makes lifelong learning in AI so exciting. It's not just about building like cool tech. It's about creating systems that can actually make a difference. So let's explore how we measure the success of these agents and look at some of the really cool applications that are popping up.
Yeah, let's do it. Okay, so we're talking about these lifelong learning agents that can supposedly get better over time. But how do we actually know if they're like living up to the hype?
Yeah, how do you measure progress in lifelong learning? It's a great question because we can't just use the same old metrics we might use for, those traditional AI models.
Right, like those usually just focus on like how well the AI performs on a single task.
Exactly. But with lifelong learning, it's not just about that one moment, right?
Yeah.
It's about how much the agent actually improves over time.
So like it's more about the journey than the destination.
Kind of, yeah. Researchers, they focus on measuring like how that performance changes. How quickly does the agent learn a new task? How well does it hold on to that knowledge? Can it use that learning in a totally new situation?
So it's like you're looking at the whole learning curve, not just a snapshot.
Right.
Okay, but are there like any specific metrics they use to track that progress?
Yeah, definitely. They often use things like the agent's success rate on a bunch of tasks, maybe getting more and more complex.
Okay.
Or how well it can handle something it's never seen before, like something that wasn't in the training data.
So it's like, can it think on its feet?
Exactly.
Yeah.
And they also want to see how efficiently it learns, like how much data does it need to get to a certain level.
Okay, so it sounds like a pretty thorough evaluation process.
Yeah, it's got to be, right?
You want to make sure these agents are actually learning and growing.
Yeah, absolutely.
But, beyond all the technical stuff, I'm really interested in the real-world impact. Like, where are we seeing these lifelong learning agents being put to use today?
Well, it's still early days, but there are some really exciting applications starting to emerge. One area where we're seeing a lot of potential is in personalized assistance.
Personalized assistance. Okay.
Yeah, imagine an assistant that really learns your preferences, knows what you need, and just gets better over time.
That would be amazing. No more having to explain things a million times.
Right. It'd be like having a partner that's like constantly learning and growing with you.
Yeah.
And these assistants could go way beyond just scheduling and reminders, right? Like helping manage your finances, planning trips, even providing emotional support.
Wow, the possibilities are mind-blowing. But it's not just limited to personal assistance, right?
Oh, no, not at all. Another area with tons of potential is in work scenarios. Think about AI collaborators that learn from how you work,
Okay.
making things like knowledge management and problem solving way more efficient.
So instead of just being a static database, it's like an active partner, right?
Yeah.
It's learning from you, anticipating what you need, maybe even sparking new ideas.
Exactly. Helping you sift through tons of data, make connections, find those hidden insights.
That would be incredibly valuable, especially in today's world.
Right.
Are there any other areas you're like particularly excited about?
Oh, definitely. The potential in like specific fields like education, law, medicine is huge.
Okay. Yeah.
Imagine AI tutors that adapt to each student's learning style, AI assistants helping lawyers with research, AI systems supporting doctors with diagnosis.
It sounds like these agents could revolutionize every industry.
Yeah, the potential impact is massive.
It's a bit overwhelming to think about.
It is, but it's also super exciting, right?
Yeah, definitely. Well, I think we've covered a ton of ground today, exploring all these different aspects of lifelong learning LLM agents, from how they work to their potential impact. It's clear that this is a field that's rapidly evolving, and it's going to be fascinating to see what the future holds.
Absolutely. It's an incredible time to be involved in AI.
I want to thank you, the listeners, for suggesting this topic and providing all those amazing research papers. Your curiosity and engagement make these deep dives so much fun.
It's been a pleasure discussing this with you.
Until next time, folks, keep those deep dive requests coming.